Good morning, students. In this video, we're going to discuss about microprogrammed control coming under the model number 5 of computer organization architecture under basic processing unit. So this video is going to deal about a control unit organization of the microprogrammed control and conditional branch instruction, how it's going to get processed under the microprogrammed control. And we're going to deal about the micro instructions and micro routines which have been used in the microprogrammed control. Let's discuss one by one in detail. Microprogrammed control. The microprogrammed control organization is implemented by using the programming approach. In microprogrammed control, the micro operations are performed by executing a program which consisting of a micro instruction. So the block diagram of microprogrammed control organization is going to be shown over here. Here, the control memory address register which specifies the address of the micro instruction. The control memory is going to be assumed to be a read-only memory within which all control information is going to be permanently stored. So the control register holds the micro instructions fetched from the memory. So the micro instructions contains a control word that specifies one or more micro operations for the data processor. While the micro operations are going to be being executed, the next address generator is going to be computed in the next address generator circuit and then transferred into the control address register to read the next micro instruction. So the next address generator is often referred as a microprogram sequencer as it determines the address sequence that is going to be read from the control memory. Such a way, the next address generator, often as a microprogram sequencer, determines the address sequence that is going to read from the control memory. Let's discuss about a control unit. The control logic and the data processor always accepts the inputs. The control logic accepts the external inputs, as the data processor accepts the internal inputs, and which is going to be producing the micro operation start as well as the status condition is going to be given from the data processor to the control logic for the next operation. Such a way it's going to be producing the outcome of this particular processing data. This is going to be the general function about the microprogrammed control unit. Here, the control signals required inside the processor can be generated using a control step counter and a decoder circuit which have been already discussed in the hardware control process. So now we can discuss a small scheme which consisting of a microprogrammed control in which the control signals are generated by a program which is going to be similar to that of the machine language programs. So here we are going to have a control word which consisting of a micro routines and micro instructions. Let's have a small example, the control sequence. So here what happens, the control sequence which is going to be producing a 7 steps over here, step action 1, 2, 3, 4, 5, 6, 7, and it's having its equivalent actions. So the step 1 is going to be consisting of an action of PC out, MAR in, read, select for, add, Z in. So this instructions are going to be get fetched in the particular example. So if you're going to see about this micro instruction step 7 are going to be get present over here, and which are going to be get specifying with the machine language programs. So the machine language programs consisting of zeros and ones, as we have seen that the PC out and MAR in read, and we are going to have an select and add and Z in. These inputs are going to become high, whereas other inputs are going to be 0. Then meanwhile, the second step we are going to see about Z out, PC in, Y in, waiting for a memory function control. So these are the 4 data sets has to be high in the state. The second micro instruction which is going to specify PC in 1 high, Y in as high, and which is going to have PC Z in, Z out as high, and MFC is going to be high. Such a way it's going to process step-by-step process of this particular all instructions of all micro instructions, and which is going to specify the data equivalent to that of the high state is going to be present as per the instruction which is going to be given over here. Such a sequence of execution of the instructions are going to be get specified the particular example add R3 comma R1. Here we're going to have one more information that a control word, the organization which is going to be dealt with this, the control word CW is a word whose individual bit represents the various control signals, and each of the control steps in this control sequence of an instruction defines an unique combination of ones and zeros in this particular control word. Such a way it's going to get processed over there. Here in this diagram, a sequence of control words corresponding to the control sequence of a machine instruction constitutes a micro routine for that instruction, and the individual control words in this micro routines are referred as a micro instructions. So the micro routines for all instructions in the instruction set of a computer are stored in the control store, a special area or a special memory called as control store. The control unit can generate the control signals for any instruction by sequentially reading the CWs, nothing but control words of the corresponding micro routine from the control store. So this suggests organizing the control unit to read the control word sequentially from the control store. A microprogram controlled or a microprogram control WMC is going to be get used over there. Micro PC is going to be get used every time a new instruction is going to be loaded in the instruction register. The output of this block labeled to a address, but a starting address is going to be generated, is going to be loaded, which is going to be loading into the microprogrammed controller. So the microprogrammed controller then automatically incremented by the clock signal, causing a successive micro instructions to be read from the control store. Hence, the control store signals are delivered to the various parts of the processor in the correct sequence. Such a way the operations are going to be get made over here. One important function of this control unit cannot be implemented simple organization, since this is a situation that arises when the control unit is required to check the status of the condition codes or external inputs to choose between the alternative courses of an action. So in that case, we are going to have a small modification with this particular inputs. So the hardware control, the situation is going to be handled by including an appropriate logic function in the encoder circuitry. So in this microprogrammed control, an alternative approach is going to be use a conditional branch instructions. In addition to the branch address, this micro instruction specifies which of the external inputs and the conditional codes or possible bits of the instruction register should be checked as a condition for branching to take place. So hence this diagram allows the conditional branching in the microprogram. The instruction, when we're going to take about the branch is going to be greater than 0, may now be implemented by a micro routine such as shown in this figure. So after loading the instruction in the IR, a branch instruction transfer control to the corresponding micro routines into the micro routines, which is assumed to start a location 25 in the control store. So this address is the corresponding output of starting address generator block code. If this bit is equal to 0, a branch takes place to a location 0 to fetch a new machine instruction. Otherwise, the micro instruction at location 0 to fetch a new machine instruction. Otherwise, the machine instruction at location 27 loads in the address in this program counter. So let us discuss about this particular operation with help of this particular conditional sequence. So as we know that in this address, the output address generator blocks codes, if the bit is equal to 0, a branch takes place to the location 0 to fetch a new instruction. Otherwise, the micro instruction at location 0 to fetch a new instruction. Or else it's going to take the location at 27 and load the address into the program counter. Such a way it's going to do its operation. So to support the microprogram branching, the organization of the control unit should be modified as like this. The starting address generator block becomes the starting address and branch address generator. This blocks adds a new address into the microprogram controller when a micro instructions it to do so. To allow the implementation of the conditional branching, inputs to this block consisting of an external inputs and conditional codes as well as the content of the instruction register. So in the control unit, the particular microprocessor control is incremented every time with a new micro instruction is fetched from the micro program memory, while expecting some of the situations. Three situations it's going to expect. The first one, when a new instruction is going to be loaded into IR, then the microprogram control is loading with the starting address of the microprogram routine for that particular instruction. When a branch instruction is going to be loaded or encountered and the branch condition is going to be satisfied, then the microprogrammed controller is going to load with the branch address. When an end micro instruction is going to be encountered in the instruction register, then the microprogram controller is going to be loaded with the address of the first CV, nothing but the control word in the micro routine for the instruction fetch cycle. Such a way, the organization of the microprogrammed control is going to be working.